Ashutosh and Ishwari, Anjali, Achal, Ajit, Bini, Tejas, Vishal, Radhika, Swarada, Aditya, Rasika, Harshal, Yuva, Kriti, good morning, Bhushan, Viraj, Praveen. Good morning to all of you all. Vijay also, I just forgot him. A few more have joined in. Anuja, Durvesh, Ria. Prachi is also joined in right now. Well, let us welcome you all, and of course, people will be joining in as we proceed. I've started this 10 seconds early today, basically because of the fact that I am in the college. I am conducting the lecture from my car because I have some work in the college as such. I hope you are able to hear me, and the fact that there is not much disturbance. We can start with our lecture. I said that we would be starting with the geological time scale. But in addition to that, of course, we are going to move on to the geological time scale. But in addition to that, I found out a few slides yesterday. In fact, it was a presentation, and I just borrowed a few slides from that, and which is in relation to the equinox positions and the confusions we tend to have as far as those positions, etc., are concerned. So I thought of putting that together first, and then having understood the geometry and geography of that, we will then move on to the geological time scale as such. Okay, I don't have any news bulletin for you all. I've already said that from Thursday we start with our Diwali break. It's not a vacation; it's just 5 days, and next Monday you would not have your Geography 1 lecture. That's basically because it's going to be a holiday as far as Diwali vacation is concerned. Tuesday, however, is a working day, but you will not have your geography lecture on Tuesday because I would be on leave. You may have your other lectures, but geography lecture is not going to be there. With that details, let us move into a few things that we did yesterday. And then, yeah, if you remember, we stopped here. This is the international dateline, and the dateline is nothing but the 180 degrees longitude. Okay, and an obvious question would be that if this is 180 degrees longitude, why is it that it is not curved or straight? Okay, it is basically because of the fact that to accommodate a few political entities, political in the sense space-wise political entities within a particular thing. Now there is an issue as far as this is concerned. I'll just change the setup a bit, and we'll come back to that in a moment's time. Just give me a couple of seconds, and I should be able to get you through for that. Yeah, I had just set up a different view. I've changed the view, and now they should be fine, I suppose. Yeah. I hope now this gets us into the proper mode as such. Now you can see a larger view as far as the world map and of course the international dateline is concerned. Tilted a bit in the northern hemisphere, tilted a bit along the equator, and then further south, basically to accommodate islands of New Zealand and etc. etc. I also said that as far as gaining time and losing time and the other aspects, these are the questions normally you tend to have as far as your competitive exams are concerned, or those very fuzzy quizzes that you have. I said that the only thing you have to remember is your own location, and if somebody speaks about the say the prime meridian, it remains the same. Okay, you imagine yourself to be on the prime meridian. Okay, so it's very individual centric. If an individual is traveling towards her own right, say towards the east, not right or left, let us not confuse ourselves. to the east, you'll see that she is going to lose time. If an individual is traveling towards the west, she is going to gain time. Okay, this is the basic principle you have to keep in mind as far as gaining or losing time when you are moving along east west along the surface of the globe, anywhere as such. Of course, there would be a difficulty if you are standing on the pole, and how this is to that's a very interesting scenario as to what should be the time position, etc., if you are exactly at the poles. Fortunately, we don't have much habitation on both the poles. As a consequence, we are not faced with that type of an intriguing question, I would say, as of now at least. And let us leave it there itself and let us move ahead. Yes, this is something that I wanted to speak about. And let me just enlarge it a bit for you all. Okay, you'll see that as far as these positions are concerned, let me just, yeah, as far as these positions are concerned, you'll see that when the North Pole is facing the sun, okay, is facing the sun, in the sense I have told you all that all these are relative positions, and I have asked you all to look into the geometry of that. I did point out that if you add up 23.5 degrees and 66.5 degrees, it comes to 90. So all these issues about Tropic of Cancer and the Arctic and the Antarctic Circle, along with the Tropic of Capricorn, etc., is concerned, it makes things very, very interesting. Basically, because of the fact that there is a lot of geometry and angles involved in that. Now, if we are referring to 21st of June condition, which you can see as a major part of your slide in front of you, you'll see that on that particular day, the sun's rays are more or less perpendicular on 23.5 degrees. Now, why is it 23.5 degrees? Basically, because you'll see in its journey around the sun, the Earth comes to one particular end, and it is here that the North Pole tilts towards the sun to its maximum, or I would say relatively tilts towards the sun to its maximum. And as a consequence, now why does this happen? Basically because the angle of the axis of the Earth, tilt in the axis of the Earth, is 23.5. So going by that particular geometry, you'll see that on that particular day, the sun's rays are going to be perpendicular on 23.5 degrees. Okay, and you'll see that here you're going to have a significantly long day on this particular thing. Now, if you remember, I did speak about the fact about the 66.5 degrees and what happens to 66.5 degrees. If I have not, okay, you can just see the zone of illumination and how 66.5 degrees is associated with that as such. Okay, you'll see that as far as 66.5 degrees is concerned, of the hemisphere which is facing the sun, it is going to be a 24 hours day all along 66.5 degrees. Exactly opposite to that, okay, the hemisphere which is away from the sun, and in this picture it's the southern hemisphere, you'll see that whole of 66.5 degrees is going to have a 24 hours night as such. Okay, so that's an interesting thing to note as far as these aspects are concerned. That is how the the geometry transfers into the geographical aspect as such. And you'll see that exactly opposite things happen as far as December positions are concerned. You'll see that the days are longer now as far as the southern hemisphere is concerned. And along 66.5 degrees, now you have 24 hours night, while 66.5 degrees south, you're going to have a 24 hours day as such. On the other hand, as far as the solstice positions are concerned, you'll see that on this day, okay, the north and the south pole are relatively straight, basically because of the fact that these are positions wherein the axis is parallel to the sun and not facing towards it or away from the sun. As a consequence, you'll see that technically we can say that it's a 12-hour day, 12-hour night. But if you have observed this, or you can observe this next time, I'll of course keep reminding you on the coming 23rd of December as to note this on the weather and radar map. Okay, we're going to I'm going to teach you all how to go into the various places on the surface, and that's going to be it's very interesting to take note of it. Now, how does the sun move? Okay, you'll see that it moves like this. So for example, a person is standing here, and this is the west and this is his east as such, and this latitude is 40 degrees latitude. This 40 to 40 degrees latitude. Now the equinoxes, the summer on the winter, or you could say the spring and the vernal equinox, or the vernal and the autumnal equinox is concerned. That's between 21st and 22nd of March, and 22nd and 23rd of uh, September. Though the day and night as given here are supposed to be equal for this person, okay, who is at 40 degrees, you'll see that all angles change with regards these locations at which you are. So if I'm at 40 degrees, you'll see that the sun is at this particular angle to me, okay, on that particular day. Okay, the sun is at this particular angle, so it will rise like this in front of me and go. It will not come overhead. No place beyond 23.5 degrees north and south will have overhead sun, or rather has had any overhead sun till today, and it will not have, okay, even in the future, as long as the tilt in the axis stays 23.5. And going by the Milankovitch cycles, though it would go as much as 24, you'll see that 25 degrees north and south will never had overhead sun. Okay, so that is an interesting important aspect we have to remember. Then let us continue with the same thing and try to understand it in this particular way. This is how this diagram in the right is shown in a geometric way here. You'll see the angles now. Okay, the Tropic of Cancer is 90 degrees. The sun's rays are 90 degrees. Okay, at the equator, okay, they are going to be less. When are they going to be 90 on the equator? Either in March, either in September. In June, it is going to be 90 degrees at Tropic of Cancer. You go further up, okay, 66.5 degrees, it is 47 degrees, and at the poles it is as low as 23. Again, you can understand the geometry in here as such. Okay, at the same time, as far as southern hemispheric, why is it that 66.5 is in night time? Basically because the sun's rays are 0, you can see here, while it is 43 as far as Tropic of Capricorn is concerned. These figures will inverse during December. Okay, this 23 will come here, this 47 will be at 66.5 degrees, 90 degrees will be now at Tropic of Capricorn, and you'll see that 66, however, will remain the same. It will not change much. So the reason why we have so much of energy along the equator is the minimum angle to which sun's rays come to, minimum, is 66.5 degrees. And you'll see that as far as other areas are concerned, they go much below that. So that's very interesting. That's very important to remember when we are doing climatology and the duration of the day and the night, and of course the other aspects as far as the sun, the inclination of the axis, etc. is concerned. Then there are a few more things that we need to understand here. Is what happens. Okay, now you'll see that this is the very position. The top diagram is now mirror imaged. Okay, the diagram here, this diagram is now mirror imaged as far as this is concerned. And to understand it better, what they have done, to the right of this diagram, you have a northern view. Okay, that as if you have taken a drone over the North Pole and you're watching the Earth from the northern pole as such. Now you'll see that what is seen here is now being seen from the top, and there you'll see that the shadow of night is just touching 66.5, and that is why whole day you're going to have sunlight here. On the other hand, what happens during the equinoxes? What happens during the equinoxes is that the axis is more or less perpendicular. As a consequence, when I'm looking at the same thing from the pole, you'll see that it divides the Earth pole wise into two parts, and that is why it is approximately 12 hours of day and 12 hours of night. And exactly the opposite position happens as far as the December solstice is concerned. So these are interesting things that we have to remember. And given these things, what exactly happens as far as the energy is concerned? You'll see that as far as 0 degrees latitude is concerned, equator is concerned, you'll see that the insolation from the sun, this is January, February, March, April to all the way to December. You'll see that because equator, it does not change, the energy along the equator is more or less the same. And interestingly, you'll note that during the March equinox and the September equinox, it is relatively higher. On the other hand, June solstice and December solstice, it is just lower. It's not very low as such, but it's just lower. And that is why equators are full of energy and the sun's light is such. Now, coming to 30 degrees, say north latitude. Now, this would be say you just have to change the months down. If I am to put it for let us say the southern hemisphere. Okay, now you'll see that as far as say 30 degrees north latitude is concerned, January is okay. You'll see that November, December, January is our winter, so the insolation is going to be less, but then it peaks up during June, July, August, and then again it comes down on this side. So this is how you read this. And then as far as 60 degrees latitude is concerned, all these are very similar to what the latitudes we have been watching for quite some time. Okay, you'll see that January again, it's going to be much, much lower because, and it's going to be chiller because of its winter in the northern hemisphere. Then it slowly rises all the way up to June, July, and then of course it falls again down. What is interesting is 90 degrees. You'll see that unlike these three latitudes, wherein they started before the origin, okay, they started before the origin and they stay there after the December also. Unlike that, you'll see that as far as 90 degrees north is concerned, it is March to September. Now, what does that mean? That means that along 90 degrees, the sun rises in March and it will stay there for the next 6 months. And at the end of September, it will again go, say, below the horizon, and you're going to have night again. Okay, and you'll see that while this period continuously you're going to have sun. Okay, this is called as the polar day part. And as far as the winter of the northern hemisphere is concerned, that's October to March, it's going to be called as polar night. I'm going to of course post the these screenshots of the weather and radar app on our group at a later time, but you'll have to remember these things tend to happen. Now, that is all as far as all these things of the earth, etc. We have been doing all these things, and that is why I thought of clarifying it. I'm very sure that a lot of you all who could be confused about this, and I wanted to remove that confusion. In spite of that, if you have any confusion, please let me know on the group individually or on the group as such. We could discuss it again on the group, or say for some time in the next lecture also. Now let us go to something that we were supposed to be doing right away, and that is the geological time scale. Now, what is the geological time scale? You'll see that it is basically a measure of measuring how the earth or what the earth has experienced throughout these times as such. Okay, and in fact, you'll see that it's very interesting to note that how man has changed his perception about the age of the earth. You'd see that we did not know that the earth is so very old. In fact, till 50 years ago, say today it's 2020, till 1970 we did not believe that the earth is 4.6 billion years old. 4.6 billion years. In fact, till 1950 60s it was believed that it is 3 billion years old. Okay, you'll see that technology and various methods of research have always been say presenting us with new figures and new facts, and as a consequence, as of today, we believe that the age of the earth is supposed to be 4.6. Who knows, tomorrow there could be another development in technology and the earth could grow a bit more older. It could be 5 billion years, it could be 6 billion years. But given the present technology available with us, you can be very sure to say that as of now, okay, and it's more or less finalized that the age of the earth is 4.6 billion years. Again, I'm keeping my fingers crossed. Say in 50 years time from now, who knows, you will see that the age has gone, and in fact you'll see that why this is a concern, basically because, as I said, that not more than 400 years ago we believed that the earth was a few thousand years old, only a few thousand years old. And in fact it was some religious bigots in on the European continent who actually claimed the birthday of the earth also. It was somewhere around 16th of October 10,000 years ago, etc., etc. And at that particular point of time, the church, okay, the church had a very strong hold as far as the continent of Europe is concerned, and whatever the people representing the church said was supposed to be taken to be true, even if you believed it or not. But you'll see that things changed after that. In fact, there was this person called by the name James Hutton. Now, James Hutton is, by the way, as far as this lectures, okay, I'm sure we are not going to finish it today. We are going to, of course, say spill over into the next lecture. So that's why I'm saying that these lectures that I'm delivering on the geological time scale have been taken from two sources. One is basically a book by Professor P. Dayal. Now, P. Dayal is a former vice chancellor of the Bihar of the Patna University, and then a few interesting facts that I'm going to present you all with along with this have been taken from say the documentary How the Earth Was Made, which I think I shared with you all, but if I have not, and even if I have, it's just going to be a repetition. It was a BBC film which was screened on the History Channel. Okay, we have a copy of it, and normally when we are on campus, I do screen it for the students in the class. Now, yeah, I think I did ask y'all that if anybody of y'all would suggest me the way as to how this could be screened online, this would help like anything. And of course, it's not more than 90 minutes, so we could surely screen it in 2 hours, if not 1 hour as such. And that would be very helpful to you all, basically because geological time scale is something that encompasses mathematics, that encompasses statistics, that encompasses earth sciences, geography, geology, that encompasses biology, that's zoology and botany. And of course, the mechanisms around this cannot be done without physics, the instrumentation part, and of course chemistry. So for a science student, it is interesting to at least know what the geological time scale is, and so on and so forth. So with all these references, we need to go ahead. And in fact, you'll see that these interesting things have been mentioned in that documentary, that it was James Hutton, who was a Scottish farmer in Scotland. And while he was farming, of course, he was a rich farmer. While he moved along his farms, he became very interested in rocks. And while he became interested in rocks, he became interested in rock types, and then he started traveling, looking for rocks, etc., etc. And then you'll see that along some coast there, he realized that as far as rocks are concerned, sedimentary rocks, he said, basically are because of layers being deposited. And he said that the age of the earth can be defined on the base of how thick this layer is. He took sedimentary rocks and he understood and tried to understand the thickness of the layers as far as these sedimentary rocks are concerned. You'll see that these sediments could have settled in glacial deposits, in river deposits, and other deposits. A particular year where you have lots of rain, the river brings in a lot of material, and that year's layer could have been thick. You wait for 1 year, next year you may not have that much of rain, so erosion is less, and the say the layer could be a bit say thinner. So he said that we could use this technique, sedimentation technique, and accordingly he said that it's not a few thousand years, but it could be tens of thousands of years that the earth is old about. But then while the scientists say in different parts of the world started looking in for and trying to study about the age of the earth during that particular phase, different scientists took around different methods and ways of possibly detecting, okay, because you'll see that the moment they saw the say the volcanic eruptions taking place and displacing what was earlier, they said that rocks, it would be difficult for a particular period. Yes, you could date a rock and etc can be done, but for a longer period it is doubtful, basically because once you have a volcano, it could be covering the surface and the rocks are gone forever. So they said that we should look into something which is more sturdy. And they thought that, okay, what something that is going to be more sturdy is salinity. They knew that as far as the salts in the oceans are concerned, namely sodium and chlorides and so on and so forth, they are actually drained from the from the land surfaces as such. Now in this process, what is happening is the salinity of the ocean is increasing, and as a consequence they said that, okay, well, if today the salinity of the oceans is 35 parts per thousand. Okay, remember, salinity is measured per thousand and not per hundred. So that's, they said that if it is say 35 parts per thousand, it could have been lesser a period, it could have been lesser. So they tried to measure it, and they said, and they came to a conclusion that okay, probably it's not tens of thousands, it's a few million years that the earth is old for. Then comes in Kelvin. Okay, the chemistry students will know that they, of course, all of you all literally have chemistry, so students will know that you have different measures of measuring degrees. So you have degree kelvins, that is based on say the alcohol being used as a measurement. Now it is that particular Kelvin, and because of that he was honored with the honor of being Lord. So he was Lord Kelvin, and Lord Kelvin worked around the thermodynamics. Okay, and he said that if we believe that the surface of the Earth during the starting point of the formation of the Earth, it was molten. You had literally rivers of lava flowing instead of rivers of water that we have today. He said that, and from that particular time, you have come to a point wherein you have only some points on the surface now which spew up lava. Most of the lava is in fact in the interior of the Earth. He said we can calculate it through laws of thermodynamics. He said that if a particular surface takes so much of time to cool down, okay, he said that okay, 1 meter of thick lava could take around 400 years to solidify. So consequently, he says that okay, if it is 6,500 kilometers all the way to the center of the Earth from here, it could have taken a few hundred, at least, if not a few thousand million years, as far as cooling down is concerned. So he said that probably it is a billion years plus as far as the cooling time is concerned. So obviously the age of the Earth is going to be a bit more than that. So it's not a few hundred million years, it's at least 1,000 million years that now Kelvin started saying that the age of the Earth was. By this time, this was somewhere around 1898. Okay, by 1900, there was this new maverick who was an excellent scientist in chemistry, and he started speaking about radioactivity. He started speaking about radioactive elements. He started speaking about radiation from radioactive elements. This was none other than Rutherford. It was in 1904 that Rutherford said that, well, it is not only that the source of energy that you find as far as the surface of the Earth is concerned, it is not only the molten lava. There is something else. You have tons and tons of radioactive material as far as the interior of the Earth is concerned. And what is keeping this Earth warm is basically, in addition to that, you will see that a significant contribution comes from radioactive material, is what Rutherford said. And then he started calculating half-life period, etc. And then he calculated how uranium disintegrates or decays into lead, and all that half-life period calculations that you have done in your school days in 11th and 12th as such. And he said that the Earth is much, much older. Okay, it's not 1 billion years, probably it is 2 billion and more years old, old as such. And as I said that then by 1912 you have Wegener, who starts speaking about continental drift and so on and so forth, and then he goes tracing back into history and so on and so forth. So this is very interesting to note as to how these things may have changed. And say, as I said, that by 1960 or 1970, we started came to a sort of confirmed conclusion that probably the age of the Earth is much, much more. It's 4.6 billion years old, and so on and so forth. So as far as this aspect is concerned, how is this 4.6 billion years old, or age of the Earth understood? You'll see that we will highlight this, the left column. Okay, don't look into the right columns as of now. You'll see that we start at 4,600 years old, and you'll see that that is called as the Priscon period. Now this is the first 500 600 million years, okay, or half a billion years, you could say. This is when the Earth was just into formation. As I said, the surface was very molten, and everything was moving and the surface temperatures were deadly. They were as high as the surface temperatures of the sun itself. But gradually, in half a billion's time, you'll see that it cooled down, and you started having the first of the land surfaces. Now this is something like मराठीमध्ये त्याला आपण दुधावरची साय म्हणतो. You'll see that the scum started coming up to the surface. Okay, the scum of this matter, the lighter matter started coming up to the surface. These were called as the first, say, um, indicators of land, and in fact, these were called as cratons, Cratons. Presently in geology, they are called as shields. Okay, you will see that such comes came up to the surface. Okay, they rose to the surface because they were less in density. These were called as shields, and they came up in different parts of the world. And in fact, you'll see that all present continents have grown around these areas, these shields as such. If you go to North America, there is the Canadian shield. If you go to South America, you have the Brazilian shield. If you come to Africa, towards the southern part of Africa, you have a large African shield as such. You go to Europe, you have the Arabian, say the Siberian shield as such. And of course, be very proud when I state this, that the peninsular part of India is also a shield. Okay, in fact, in it's one of the smallest shields, but it is there. Okay, so we'll see that the southern part of India, peninsular part of India, the part on which we live here. Okay, most of us, I don't know whether we have students who are staying to the north of the Tropic of Cancer, but to the south of Tropic of Cancer, you can say that all surface that we live on is that old. It's very, 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 very old. It belongs to the Archean period. And how do you identify the Archean rocks? You'll see that because this is the early period of rock formation, you don't have any fossils. In fact, leave aside larger fossils, you don't have micro organic fossils in these rocks as such. You have to wait for, say, around 2 billion years, another 2 billion years, and it is after that that you start having rocks which have some life in that. Okay, life in the sense this is microorganic. Okay, this is a life which can be seen only in under microscopes and compounded microscopes, if not simple microscopes as such. But you'll see that this is a period 2,500 million years or 2.5 billion years ago till around 500 or half a billion years ago, wherein you have some evidences of life. You can't say that no, there is no evidence of life. There is. You don't have it in abundance, but you have some evidence. And in fact, you'll see that they found a way of naming these accordingly. Okay, now it's called as Proterozoic. Now, why is it called as Proterozoic? You'll see that zoic basically means life. Zo means life, and zoic means towards life. So pro means towards life. Okay, so the earth was moving towards life. Okay, for the first 2 billion years, you could not say that life is there, but you'll see that towards the latter part, you could definitely say that yes, we don't have large form of life, but very soon we should be having some form of life. Because there are evidences of some form of life, we could definitely say that yes, we are proterozoic towards life as such. Okay, and in fact, you'll see that towards the last 500 years or 500 million years, sorry, you have larger forms of life, and that is called as the that form of life. In fact, again, is divided into three forms: Paleozoic, Mesozoic, and Cenozoic. Now, zoic obviously is life, but what does paleo, meso, and ceno mean? Paleo means an older form of life. Anything that if you're studying anything old, very, very old, it is called as paleo. Paleontology is basically the study of old rocks, etc. So Paleozoic is something which is a very old form of life. Mesozoic is a medium form of life, and Cenozoic is modern form of life. Now, as far as Paleozoic, or rather Mesozoic, is concerned, you'll see that Mesozoic is the period, or rather the era, not period, sorry, the era wherein you have the dinosaurs as such. And in fact, you'll see that now we have a lot of data regarding these 500 million years. So unfortunately, we have, or fortunately for students, you could say that we have not much to learn about. Now, just imagine if for the last 500 million years, you have so much amount of data available. If we had studied all the way from the first day of the formation of the earth, it would have been it would have been a very voluminous thing to understand and to learn all these things put together. As a consequence, let us speak about these large animal formed or large life formed era, that is the Paleozoic, Mesozoic, and the Cenozoic as such. Okay, of this, the Paleozoic is the oldest, and you'll see that it starts from the Cambrian period. The Paleozoic is divided into periods. Now you'll see that this was the era here, and era are further divided into periods. Okay, then, as far as these eras are concerned, you have the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. There are interesting stories about each of these eras, but obviously the scope of your syllabus does not allow us to go into those stories as such. But a few to tell, you'll see that all the period before this Cambrian period is called as Precambrian. Sometimes all this, the left hand column that is just lies below the Paleozoic, everything is called as Cambrian. Okay, everything is called as Precambrian. Okay, then you'll see that some geologists divide this Precambrian aspect into three. The Hadean, the Priscoan is also called as Hadean. Okay, or that's the very wild surface, that's the very molten surface. Okay, the very volatile surface of the Earth is called as the Hadean period. Harder surface but without any life is called as the Archean period. Hard surface but with very microorganic life is called as Proterozoic. And after that, of course, you have the Cambrian and so on and so forth. Okay, so this is the Paleozoic period, and then you have the start of the Cambrian period. Now, remember that, and of course, you can note here that the thickness of these will show that all these are not geometric divisions, mathematical divisions. It's not that they take a 6 and they divide it by 2, and then you have three parts of 2, 2, 2. You'll see that all this is related to the how life was evolving during that particular point of time. So you'll see that the complete set of life which was there during the Paleozoic, that is the older form of life, was much different to the type of life which followed, and that is why these three together are called as Mesozoic. And then you have the Cenozoic, which is further divided into Tertiary and Quaternary. Now some say that Tertiary and Quaternary are not periods but they are eras as such. Okay, there is a lot of confusion about that, and let us not go into those confusions as such. But remember that we know whatever details we know about the geological time scale, you'll see that it's only 10% of the total history of the Earth. Okay, 90% of it is still not known. Whether we would know it, whether we would not, is something again that we would wait for, and technology only would help us to go into the details of that. Before I confuse you more, let me, with these numbers and figures as such, let me show you that since we have come to the Paleozoic, how did life change as far as the Paleozoic from the Paleozoic period is concerned. You'll see that before the Cambrian, the Proterozoic, you had very unique type of animals here, smaller in size, and you'll see you had trilobites, etc., etc. By the Cambrian period, okay, you'll see that you start having chordates. Okay, students of zoology will know what chordates are. You had the first fish who came up in the Cambrian period also. Okay, and they grew in various size. Okay, so the Cambrian period lasted for a couple of hundred years, a couple of 100 million years as such. Sorry, say around 50 million years. And by the way, 50 million years is 10 times more the time man has been on this particular planet. Man has been on this planet for only 5 million years. And the Cambrian period, remember, lasted for 50 million years. So you had the first fishes, you had the first chordates during the Cambrian period. Then from the Cambrian, you'll see that the metazoan families, they started diversifying during the Ordovician period. And that is why this is a separate period. You'll see that when scientists locate a change, they have named it as a different period as such. Okay, the Ordovician period, you have the diversification. It's during the Silurian period that you have the first hint of land plants, vascular land plants as such. And then you go to Devonian period. Why is the Devonian period interesting? You'll see that now you have jawed fish. Fish had jaws as such, one thing. And secondly, first of the amphibians came up during the Devonian period. Okay, so possibly now again, scientists are divided whether life came up on land first or whether life came up in the water first. Okay, we are still debating about this fact, but majority of the scientists believe that it was during in the water. Now my question to you all is, why is it that scientists strongly believe that it is in water that life first evolved and then it shifted to land? Okay, you'll see that as far as the amphibians here are concerned, what are amphibians? You'll see that these are animals who can live in water as well as on land. A frog is an amphibian, for example. A turtle is an amphibian as well. They can live in water, they can live on land as such. I believe that the evolution of amphibian is the first trace of nature trying to push life out of water. Nature tried to push life out of water slowly, slowly, slowly. And when I'm saying slowly, please, it's not slowly as what we mean it. It is slowly in a geological scale. It could be a few tens of hundreds of millions of years that you are slowly pushing life onto the land. And there could be so many types of animals which may have come up and perished during this particular phase as such. Then we come to the next phase wherein you had a proliferous growth or prolific growth of vegetation on the surface, and that is why this is also called as the Carboniferous period as such. You had huge growth. Now it is believed that during this particular phase, the percentage of carbon dioxide on in the atmosphere was very high. Average temperatures were very high. Because of this, photosynthesis was very high, and because of that, you had a huge growth of plant life. And in fact, you'll see that the best of the coal, the anthracite coal that is mined in different parts of the world, it is believed to be, and in fact, it has been dated to be as old as the Carboniferous period. Now, if you look on the internet for the geological time scale, except for American authors, okay, they use Carboniferous as one name or one period for this particular age. But if you see American geologists, they tend to divide this into two. The Carboniferous is further divided into the Mississippian and the Pennsylvanian. Okay, Pennsylvania, by the way, was the state which was much in discussion as far as the present elections, presidential elections in the United States of America was concerned. So some connection with that. You'll see that they divide the Carboniferous period into Mississippian and Pennsylvanian. Otherwise, in other parts of the world, they continue with Carboniferous. Okay. Then towards the end, the last of the period, as far as the Paleozoic era is concerned, is the Permian. Okay, you'll see that it is during this particular phase that reptiles started diversifying, and the major extinctions did occur during this particular phase. And that is why you'll see that at the end of every major evolution phase, you'll have an extinction. It is believed that there have been at least 4 extinctions before this, at least 4. Okay, and it is also said in a very dreadful manner that man could be responsible for the 5th, which could be one of the major extinctions on this planet as such. So you'll see that towards the close of the Paleozoic era, you have a major extinction. Now, how did extinctions occur? There were many reasons. You'll see that climate change was one of the major reasons. Climate change could happen because of various reasons. As I said, climate change, we have seen this earlier also. Milankovitch says how climate change do take place. Climate change basically is the pendulum basically oscillating between a very hot earth and a very cold earth. So when the earth started moving from very hot towards very cold, animals adapted to the hot type of climate would go extinct. When the earth started moving from very cold earth to a very hot earth, the animals who had adapted themselves started going extinct as such. There were collisions, particularly if you see towards the end of the Mesozoic era, there were collisions. You had huge meteors which came and banged into the earth, and that led to problems. So there were many reasons why different extinctions occurred. Okay, you'll see that then mountain building activity, particularly through what is called as volcanic eruption, is another source of this. And you'll see that towards the end of the Permian period, you had a major mountain building activity. Because of that, it is believed that in fact, if you tally Wegener's theory, those of who would recollect, Wegener's theory is basically the continental drift theory, that the continents are moving. And you must have heard about the name the Pangaea and the Panthalassa, and the Pangaea splitting into Laurasia and Gondwana. This is believed to be happening during the Permian period. It starts at that particular point of time, is what Wegener says. So possibly the breaking up of the continents was because of volcanic eruptions and other activities in the interior of the earth, which led to major extinctions of major forms of life which thrived during the Paleozoic period as such. And gradually, of course, by this time, the reptiles had come up, and you'll see that the next uh, um, era, the Mesozoic era, in fact, was to be dominated as far as the reptiles were concerned. You'll see that the Mesozoic is divided into Triassic, Jurassic, and Cretaceous. Why are movies on dinosaurs related to Jurassic? Basically, because of the three periods in the Mesozoic, you'll see that Jurassic is the center one. If it is the center one, you'll see that life in this style had settled significantly during this particular period, and that is why this is supposed to be the best period. And that is why whenever we say dinosaurs, the period that we remember is Jurassic. But you'll see that before Jurassic you had Triassic, and after Jurassic you had Cretaceous. However, you lead to a second phase of extinction at the end of the Cretaceous period. As such, there is an interesting way of remembering these names. I will let me see if I can come to that and refer to that. But as I said, during the Triassic period, it's the first of the dinosaurs started coming up. They started growing larger in size, and of course, nature made way to another type of animal, and that is say the first of the mammals. As such, mammals, human beings belong to the mammalian family as such. But you'll see that when we say first mammals, they were very small in size. Okay, the average size of the mammals during the Mesozoic period is that of a bandicoot. Bandicoot is a large mouse, is called as a bandicoot. Marathi मध्ये घूस असते बघा. Okay, so a bandicoot is of that particular. So the average size of the mammal is during the Triassic period is of the bandicoot. But if you ask me what is the average size of the mammal today, I would say that it is as large as a Labrador dog. Okay, so say the Mesozoic and the Cenozoic have been favorable for mammals, and that is why you'll see that mammals have grown in size. In fact, you'll see that the largest of the animals on the planet today, on land you have the elephant, which is a mammal. In water you have the whale, which is the mammal. So this is, we can say, is the best period as far as mammals are concerned. But this was not so best as far as the Mesozoic period is concerned, because the Mesozoic period was the Mesozoic era, sorry, was the best as far as reptiles were concerned. And you'll see that during the Jurassic, a furthermore development happened. You'll see that dinosaurs started diversifying, their necks started growing long, the tail started wagging long, and so on and so forth. And another interesting development was first of the birds. Okay, the aves, the family of aves, they came up during the Jurassic period. Life started flying in the form of birds during this particular period. And then you come to Cretaceous period, which is the latter Mesozoic period. And it is here that now you have the first of the flowering plants. Yes, these are flowering, basically means now you come to sexual representation. You have a female organ, you have a male organ, and that is what is called as a sexual reproduction. You'll see that as far as a flower is concerned, you have the stamens, and of course you have the stigma as such. Okay, and of course you must have learned how a flower develops into a fruit. Okay, so all this started happening at the start of the Cretaceous period. What is more interesting is two more things which were to happen during the Cretaceous period. First the good thing, then the bad thing. The first good thing was arrival of the primates. Primates are basically the family of monkeys. The first of the monkeys came up during the middle Cretaceous period. But as I said, the bad thing that was to happen during the Cretaceous period was the extinction of the dinosaurs. There are various theories which tell us as to why the dinosaurs may have gone extinct. One of the most common theory is that there was this huge meteor, meteorite, which basically it was as large as the Mount Everest, and it came and banged into the surface of the Earth somewhere to the north of the South American continent. The location given is the Yucatan Peninsula. You can look for where the Yucatan Peninsula is. And it was after that that you find that you don't find say the fossils of dinosaurs. So probably scientists relate that it was because of that dinosaurs went extinct during that particular point of time. Now this gives you a feeling that they just banged, and because of the banging the dinosaurs went extinct. So it was not a split second activity. It again took a few thousands of years. Now as to how that happened, that's a very interesting story. It is believed that because the meteor banged with such a powerful thing. Okay, it sent the earth into a ringing, and because of that a lot of dust came up. And because of this dusting, what happened is it formed a layer between the surface of the earth and the sun, because of which photosynthesis was restricted. Because synthesis was restricted, plant life went off. Plant life went into a sort of a hibernation. And because of that, you'll see that these dinosaurs, which by now had huge bodies, and they were basically dependent on eating and eating and eating and growing in size, you'll see that unfortunately they did not have much of food. And that is why they are believed to have gone extinct. The larger of the dinosaurs first, and then the smaller, and then the smaller. It is also believed that it is during this particular period that there was a lot of volcanic activity in Siberia also. Okay, along with that, it is also believed that the present the Sayadris mountains in Maharashtra, they are supposed to have gone into formation into this particular period. Again, these are volcanic. So basically, the gases of these volcanoes got trapped, and because of that, it hampered the development of the dinosaurs. In fact, if you imagine a dinosaur, you'll see that, say, what did this species of animal think of their purpose of life. You'll see that man is looking at life in a different way. Dinosaurs may have looked at life from a different way. You'll see that given the size of, we spoke about human size and how do you divide the various sections of human body. If you do the same as far as dinosaurs are concerned, you'll see that dinosaur's head was very small, the body was huge. Now, to control this body, evolution led to a formation of a very long tail. Okay, so you'll see that you had long tails and you had long necks, but unfortunately they did not have large brains. As a consequence, you'll see that you see any of these dinosaur movies, okay, Jurassic Park 1, 2, 3, 4, and Lost World and Lost World Park, and whichever of these movies on dinosaurs you must have seen, you'll see that you can immediately remember a scene wherein there is a friction between the man, the hero, the heroine, or the children in that particular movie and the dinosaur as such. And you'll see that invariably it so happens. It does not happen only with the smaller ones, but as far as the larger dinosaurs are concerned, you'll see that you'll see that the hero or the heroine or the other characters in the movie, they'll do this tuck 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 to the dinosaur. And you'll see that when somebody does this to us, we immediately look at them. You'll see that in those movies, dinosaurs do not look very fast. Okay, you'll see that it takes time. Why does it take time? You'll see that the body is huge. You have a long tail to rudder all these things. You have a long neck, but the head size is small. Consequently, you'll see that the brain size is small. For all this to be recorded, and then you have for a response to be given to that particular individual, it consumes a significant amount of time, though it is in a few seconds. We do it in milliseconds. It took a few seconds for these dinosaurs. So you'll see that movement of dinosaurs in any movie that you have seen may have been very slow. Okay, you'll see that it's only peculiar species, and that to the hunting species, which are shown to be faster. Most of them, the vegetarian ones particularly, are seen to be very slow. Okay, because of the brain size being smaller when you compare it to the body size that it has to control for. So that ends the Mesozoic period. The next time we meet, we are going to go and come up with the modern form of life. How does man evolve? Okay, we are going to go into that. Okay, how do mammals diversify in this particular period as such? Okay, but that's going to be for the next time. We are going to stop here today, and let me come back and check if you have any questions. If we don't have questions, we will stop. Yes, I have something. Yuga says that the deep oceans where nitrogen is in the form of nitrogenous oxide could have reacted with carbon dioxide, bubbling forth from hydrothermal vents to form the first molecular building blocks. In fact, it is believed that it is the volcanic eruptions at the base of all say oceanic oceans which provided the energy to the early form of life. Okay, yes, this there are many theories, of course. I can't say that you are right and I am wrong, or I am right and you are wrong. There are multiple theories of life or evolution of life. So until and unless we have a very confirmed source, we can agree to all of these. There is one more point here. Akshata says that what kind of questions will be asked? Oh God, this girl, you are so paranoid about exams. Okay, exams is still far. You enjoy learning these things. If you have learned this earlier, you revise these things. If you have not learned this earlier, enjoy learning these things. You'll see that, let me assure you that you will not have very serious and long questions on geological time scale, but understanding a geological time scale becomes very important as far as a science student is concerned. Okay. um, it's very unfortunate that I was unable to convince you to the fact of, say, concentrating on the subject matter. Your question basically means that you are still concentrating on, my God, so many words and this and that. See, that is my job. I'll make these things easy so that you understand it in the best way. Your question is what kind of questions will be asked related to time scale and this evolution of Earth, and thus what topics shall we read from reference book. You'll see that you won't have a reference book as such in geography as such. So my discussion on this should be more than enough as far as this whole issue is concerned, and it would be related to only a few fill in the blanks here and there and a few basic lines. So let me assure you that your answers would not be your answers to the questions required would not be required to be more than 50 words and so on and so. It's very basic thing. This is a supplementary of geography. This is not core geography. So you would not have questions very core on say the geological time scale. So don't worry about that. And I am there to help you out. So don't worry about that. Radhika says that, sir, will you please revise this topic, that is geological timescale, because it's a bit confusing. Yes, I know it is confusing, and that is why Akshata had a problem about, and she got scary about what type of questions. I'm very well aware of the fact that this is a bit confusing. Next time when we meet, okay, we will go into the detail. By that time, I will post a few clips of the geological timescale on our group, so you can go through that. You can keep reading here and there. Don't go into the details. Okay, just look into the superficial aspects. Okay, don't go into the details. Okay, and that should be fine with us. It should not be very intense. Okay, that is my suggestion to you all. Don't worry at all. I am there to help you as far as how to understand the geological time scale and so on and so forth. Don't have any inhibitions. Don't have any tensions. It is my responsibility to see that you pass. Okay. And that you understand the subject as such. So keep those tensions aside and enjoy learning geography. Okay, that would be my advice to you all before Diwali, because after this we are going to meet only after Diwali. I wish you a very happy Diwali, because we are not going to meet before Diwali now. We will only meet into after Diwali. So consequently, let me wish you a very happy Diwali. Don't take tension about the geological timescale. I'm there to explain it to you in absolute detail as such. Enjoy your Diwali. Come back, and we will revise geological timescale, and we'll go ahead. That's all for today, guys. As I said, and I keep saying that, like every time, stay home, stay safe. You'll see that. People have started moving out uh, as regularities. That could be a difficult thing in times to come. Remember that we are science students and we have to be logical. Let us not have the second corona wave. See that you yourself are disciplined. See that your family members and your friends around are disciplined as well. Okay. At the same time, we enjoy Diwali in a disciplined way also. Once again, wishing you a very happy Diwali. I'll be ending my lecture here. Thank you very much for being there.